Okay, the final part of simultaneous equations for you now. This is the third final method. This is the most important one. This is one that you're going to use the most often going forward. In many ways, you're not really going to see the graphical side of this again. The substitution side of things you will use from time to time, but you're more probably going to actually use that in higher and advanced higher. So this method is the one you're probably going to see most often in an exam situation. So in past papers and things, this is the one that's going to be used most often. This is the one that's going to be most prominent going forward. Okay, it's what we call elimination. So simultaneous equations by elimination. And again, same with graphical. Graphical implies that we need some kind of graph. We need some kind of visual aspect to solve it. Substitution implies that we're putting something, substituting it into something else. Elimination implies, by the name, that we're getting rid of something. And I want you to remember that going forward. The whole purpose of this, the whole point of this process is to get rid of something. And it basically goes back to the fact that what we've got is we've got equations where we have two variables. And as long as we've got two variables, we can't solve it in the same way that we normally solve equations. But if we can get rid of one of those variables, in other words, we can eliminate one of those variables, then we can solve it. Okay, and that's our aim here. But I'm going to go through a few things first of all. Okay, a few things that you're allowed to do and a few things that you're not allowed to do. And that's going to be very, very important. And there's a few things you want to be very careful of here, okay? So I've got wee Bob to help me out. So Bob's basically going to the shop. He's going to go and buy himself an apple, and he's going to buy himself a banana. It's quite an expensive shop, though. It's going to cost him £10, okay? So going back to when we looked at the graphical side of things, there's lots of different solutions to this equation, okay? And we could set this up as an equation. That's the first thing. I'm showing you this graph. I'm showing you this visually. I'm showing you this with pictures just to try and get your understanding of it a little bit clearer, okay? But the idea is we've got something along the lines of A plus B equals 10, okay? I'm just doing it in pictures just to help you a little bit, okay? But the idea is if we've got A plus B equals 10, there's lots and lots of different solutions, okay? We could say that the apple costs a fiver and the banana costs a fiver, okay? That adds up to £10, that's fine. That could be the solution, okay? But we could also say that the apple costs £4 and the banana costs £6. That's a solution as well. And who's to tell us that that's incorrect or correct? Okay. Vice versa, we could say that the apple costs £6 and the banana costs £4. Okay. So there's two numbers there that are the same, but they both apply to the different situation that we've got here. Okay. That could be an answer. We don't necessarily know if it's the correct one. Okay. We could say that the apple costs £8 and the banana costs £2. Again, we don't know. We could say that the apple costs £7.34 and the banana costs £2.66. Point I'm trying to make is that there's numerous different solutions to this equation as it is. So as it is, we can't solve it. If I want to know the cost of an apple and the cost of a banana, which is generally the idea of these equations, then I can't do it with one equation alone. Okay. So it's going to follow the same format as before, but I'm just going to show you a couple of things first. Okay, we basically want another equation here. Okay, but we can change this equation, we can adjust this equation, we can use this equation in certain ways, but we just got to be very, very careful. Okay, it doesn't necessarily matter at this stage what they cost, but I basically want to adjust this equation. As it is, it doesn't work, so I want to change it in any way I can. Okay, so one thing I could do with this equation is I could double it. Okay, I could say that 2 apples and 2 bananas. And as long as I'm doubling both of those bits, then the cost doubles. It costs £20. Okay, if I buy twice as much stuff, it's going to cost me twice as much. Okay, that is true, and the same applies for if I times it by any number. Okay, it doesn't just have to be doubled. If I have 4 apples and I buy 4 bananas as well, it's going to cost me £40. And you can see that works for both of these equations. Okay, that one times by 4 apples, 4 bananas gives me £40. And this one, if I times this one by 2, okay, I get the 4 apples, I get the 4 bananas, and it costs me £40. So they're fine. I can do that. Okay, I can times through, and the point is I have to times everything through by that same number. It doesn't matter what that number is. It can be positive, it can be negative, it can be a fraction, it can be a decimal. I've just got to make sure that each part of my equation, and bear in mind the equation here was basically A plus B equals 10, I have to take each part and multiply it by that number. Wherever that number is, everything gets multiplied by it. Okay, so I've got to be very, very careful, and this is a mistake that a lot of people make. They might want basically to might multiply by 2 and then forget to multiply the banana by 2. And as long as that's the case, you don't know the answer. Okay, so whatever you write is wrong. Okay, there's obviously going to be one solution that's right, but the chances of you getting that one solution are very, very unlikely. So if we take the apple and double it, but we don't do the same with the banana, but we do the same with the amount, that's no longer true. We start with a question that we know is true. An apple and a banana is £10. Okay, and there's certain things I can do. If I double everything, okay, it's fine. But if I pick and choose, or if basically I forget to double something, okay, it's no longer true, it no longer works. And as much as my working makes sense to me, okay, it's no longer true. So I've got to be very, very careful, okay? Right, as I say, more likely what's going to happen here is that we're going to have two equations. As long as there's just one, okay, there's lots of things I can do with it. I can double it, I can treble it, but the point is I can't do enough with it to actually solve it. So what I need is a second equation. So there might be a second situation. Start with Bob, I might also have Karen, okay? Karen's going to the shop as well, but Karen is buying 3 apples, okay? She's buying 1 banana as well, and it's costing her £16. Right, for some of you might straight away be able to see the answer here, but there's a couple of things I want to look at first of all. Okay, as long as we've got these two situations, as long as we know basically it's the same cost of an apple for each situation, it's the same cost of a banana for each situation. Okay, they're basically going to the same shop. Okay, there's certain things I can do. I can take those two equations, and bear in mind this is basically a plus b equals 10, and this is 3a plus b equals 16. Okay, I can take those two equations and I can combine them. Okay, and there's different ways I can combine them. Obviously, I can add them. Okay, so I can take those two equations, add them together, and as long as I add every single part of it, then it's still true. So in the first bit, basically, I'd have 4 apples. Okay, so the total apples that they bought plus the total bananas that they bought will cost the overall total of what they spent. Okay, so I can say that 4a plus 2b equals 26. That is still true. Okay, but more importantly, what I want to do, as I say, my aim here is to eliminate. And what I've got here is I've still got an equation where I've got a's and b's. I've still got 2 variables. But what I want to try and do is I want to get an equation where I have none of one of them. Okay, I want to eliminate one of those variables. Okay, so it's fine to do that, and in some situations you're going to have to add more of that later. Okay, but what I want to do is I want to take these two equations, combine them, so I actually eliminate one of them. And hopefully you can see here that if I take one away from the other, and it doesn't matter if I do the top take away the bottom or the bottom take away the top, I'm still going to be left with no bananas. Okay, in the same way that I did that last one, if I take the two away from each other, I'll have no bananas this time. That's what I want to happen here, but I've just got to go through it carefully and make sure that I am taking away each part. Right, I'm going to take the bottom one and take away the top one. So I'm going to do the bottom, take away the top one. Okay, and I've just got to keep everything in that order. So I'm going to do this, take away this, take away this, and this, take away this. In which case, 3 apples, take away 1 apple is 2 apples. 1 banana, take away 1 banana is no bananas. That's what I want. Okay, I'm trying to eliminate something, and by doing this, by taking away these two equations, I have eliminated the bananas. Okay, that's my goal here. So I've achieved my goal. I've just got to work it through and take away the totals as well. 16 take away 10 is 6. Right, I can't stress enough how much you've got to do each part the same. So that take away that, that take away that, that take away that. You've got to make sure you follow it through. If you forget to take away here, then it's not true, in which case it won't work, it won't get you the final answer. But what we've got here now is we've got a much, much simpler equation. I've basically got 2a, I don't have any b, so I don't have to write anything. I've got 2a equal to 6. If I know that 2 apples cost me £6, then I know that 1 apple is going to cost me £3. So I've partly solved it. I've solved at least how much the apple costs, but obviously the overall solve of this equation is to find out how much an apple costs and how much a banana costs. I want to know both of them, okay? So I've got to actually continue on and find out how much a banana costs. But you can see if I basically look at the first equation, if I know an apple and a banana costs £10, now knowing that an apple costs £3, I can see that a banana is going to cost me £7. So I'm actually substituting in at the very, very end. So I am using that kind of last method, okay? And then I'm going to find out how much a banana costs. But my overall answer is basically an apple costs £3 and a banana costs £7. And if you look through this, and you can do this a couple of times, look through this video, and you can see the different things that you're allowed to do. But if you think about it, it all makes sense. And you've basically just got to apply it to an equation situation, okay? So 3 examples now. Different letters, okay, and we're starting, there's actually another stage beyond this, okay, I'm just going to make it slightly harder beyond this, okay, but there's just lots of things you've got to pay attention to, right? You have to be very, very careful with your negatives, okay? In this first one, there's no negatives, but in these last 2, there are negatives, and they're going to have different rules, they're going to cause different problems to our calculations, so you have to take your time with them, pay attention to them, and treat them with respect, okay? Right, let's focus on this first one. We've got 4a plus b equals 17. Right, lots of solutions to that. Individually, I can't solve it, but combine it with this one, I can solve it. Okay, so the point is we're saying when you have a system of equations like this, that the a is the same in both of them and the b is the same in both of them. Okay, so I want to combine them both together by elimination so that I can find out what a and b actually equals. Okay, so I'm going to take these equations. Hopefully you can see straight away that because I have 1b, and this is going to be important later on, because I have 1b, this is what I'm going to eliminate. And if I do the top equation, and if I take away the bottom equation, I am going to eliminate the b's. That's what I want. That's my aim here. Okay. Right. People write this in lots of different ways, but the overall thing we're trying to do is take away. Some people write alongside, and if any of you have tutors or if you watch any other videos, then you might see that people say row 1, take away row 2. Right. You can do that. You can kind of make it clear what you're trying to do in each case, but you don't have to. Okay. You can just write it like this. And just make sure you in your head know exactly what you're doing each stage. Okay, but what I'm going to do is I'm going to do the first row, the first equation, and I'm going to take away the bottom one. Okay, and when I do that, I'm going to be left with 3a's. So 4a take away a is 3a's, and then I'm going to do b take away b, and I'm just going to say that I'm doing it. I'm thinking that I'm doing it just to double check. B take away b is no b's. That's what I want. Okay, so I've achieved that, and I just need to do 17 take away 8, and 17 take away 8 is 9. Now I've got an equation that's very, very straightforward. I can solve this. If I know that 3 times by something is 9, then I know that that something must be 3. I'm basically just dividing both sides by 3. 3a divided by 3 is a. 9 divided by 3 is 3. So I solved it for a. Okay, but I have not solved it overall because I still don't know what b is. So I'm going to go on to one further stage. And people write these lines just to kind of make it clear in each individual stage what they're doing. Okay, but I'm going to basically substitute the fact that a is equal to 3 into one of these. Either one of them will work, but you can see that the bottom one is slightly easier. Okay, if a is 3, then I know that 3 plus b must equal 8. And if I know that 3 plus something equals 8, then I must know that that something is 5. Okay, solve it like an equation and don't try and take too many shortcuts here. Take away 3 from both sides, b will equal 5. And then I have my final answer. A is equal to 3 and b is equal to 5. All right, don't worry too much about this stage in terms of writing your final answer. It's something to get used to because later on this is going to get a little bit more difficult. And we need to make our answers very, very clear. Okay, but at the end of the day, a is equal to 3 and b is equal to 5. That system of equations, what we mean by system of equations is basically that there's 2 of them. That system of equations is now solved. Okay, so moving on to the second one. We've got different letters, but don't be put off by it. I'm still trying to achieve the same thing here. We're still trying to get rid of the x's. Okay, the reason I'm trying to get rid of the x's is because there is one of them. So here we have 1b in each case, here we have 1x in each case. This is key to look out for. I can't get rid of the y's just yet. Later on when I teach you this one stage further, then you might be able to. But just now, because I have 1x in each case, if I combine them in a correct way at least, then I will eliminate the x's. Okay, and what I need to do that is take away. Okay, if I added, remember I can't add here, I'm not going to get rid of the x's. Okay, so I want to take away. I'm basically going to do one equation, take away the other. It doesn't matter which way around you do it, but one is going to be advantageous in terms of leaving me with less negatives. So this one has higher numbers. So if I do this bottom one, take away the top one, it's just going to leave me with less negatives. Okay, so just go through it in stages. X take away x is 0 x's. That's what I want. Goal achieved. Right, but be careful in this next stage. I've got 6 y's and I am not taking away y. I'm doing 6 y's and I'm taking away a minus y. And again, this is where a lot of people end up making mistakes, and then it makes the next stage impossible. Okay, you've got 6 y's, you're taking away a minus y, so you are left with 7 y's. Okay, if you did 6y take away y, you'd have 5 y's, in which case the next bit equal to 14 is going to look weird. 5y equals 14. Yes, you can solve it, but it's just going to give you nasty numbers. Okay, so if you pay attention, if you use the numbers correctly, then this next stage becomes easier. It becomes correct apart from anything else. So 6y take away minus y is 7y. 21 take away 7 is 14. And if 7y equals 14, then y equals 2. Just divide both sides by 7. Now that I've got that answer, I can put it back into one of the first ones. It doesn't matter which one, but obviously the top one's slightly easier. I can substitute the y for a 2, and I can solve it. X minus 2 equals 7. Okay, in which case x is obviously equal to 9. Okay, solve it like an equation, add 2 to both sides, x will equal 9, and then write your answer nice and clearly. X equals 9 and y equals 2. Easy peasy. Right, this last one looks virtually the same. There's just a couple of things we need to think about. Okay, again we're eliminating, and again we can eliminate the n's because there is only one of them, but we just have to be very, very careful here. Okay, we have to add. Okay, because if you did n take away minus n take away minus n is 2n. It's not eliminating n. So there's going to be different situations. Sometimes you are going to take away, okay? And I know the idea of elimination implies that we have to take away, but it depends on the symbol that we've got, okay? We can eliminate by addition, okay? So n add minus n is going to give me 0 n's. That's what I want, and that's what I have to do to be able to eliminate, and then in which case I have to add everything else as well. So I'm going to add these two equations together. If I did this equation, take away this equation, I'm not going to get rid of the n's. As much as you might write that you have got rid of the n's, everything else doesn't follow suit, in which case it's not true, in which case when you solve it, it's not correct. So think about it at this stage. A lot of people say if it's the same signs, then you subtract. And that's quite a good way of doing it. So you're looking at these ones. The b's had the same signs, so we subtract. The x's had the same signs, so we subtract. Here, it's the n's that we're eliminating, but they do not have the same signs, so we do not subtract, we add. If you follow that, then it makes your life a lot easier. But just think about what's actually going to happen when you do subtract or add. Okay, bottom line is here we have to add everything else. 9m add m is 10m's. N plus minus n is 0 n's. Just double check it, that's what we want. And then 104 plus 6 is 110. If 10m's equals 110, divide both sides by 10, and we get m equal to 11. We've got m equal to 11, we can substitute it back into the start, and we get 11 minus n equals 6, in which case n must equal 5. Okay, I could have done it with the other one. Okay, if I substituted my m in here, this equation for 11, I still would have done the same thing. 9 times by 11 is 99, plus whatever n is 104. And if I solve that, I still get n is 5. It's the same with these other ones. And knowing that means that you can check your answers. If it doesn't work for both of them, then you've done something wrong earlier. And this is one of these things that you can go back and check. At the end of exam, when we say check your answers, these are the kind of things that you can check. You can use your answers to check that everything else is correct. Okay. Bottom line is, final answer is m is equal to 11 and n is equal to 5. We've solved them by elimination. Right, these questions have all been set up in such a way that this is slightly easier. These are going to get slightly harder. I've made them so that the b's and the x's and the n's have the same basic coefficient. There's the same amount of them. Okay, but going forward, that's not always going to be the case, in which case you have to apply other methods. But just now, as long as we've got the same amount of n, we can eliminate them in one step, and then we can follow through to find the rest of the answer.